Hello, sixth grade scientists. Welcome back. So yesterday we were talking about properties of a liquid, and we were talking specifically about viscosity. So what is viscosity? Well, let's review. Viscosity is the property of a liquid that describes how fast or how slow that liquid will flow. Now remember, viscosity is affected by gravity and friction. Remember we talked about yesterday the syrup, and syrup slows very slowly. It has a high viscosity. Why? Because the molecules are so big and they get entangled in one another, and so when they get entangled they flow much slower. But then we were talking on the other hand, water has a low viscosity. It flows freely. So that's kind of a recap of what we did yesterday. So yesterday I also talked to you a little bit about non-Newtonian fluids, and we talked about discussing more about that today. So to begin with, we're going to start by talking about Newtonian fluids, and then non-Newtonian fluids are the opposite, non meaning not. All right, so Newtonian fluids. Most fluids are classified as Newtonian fluids. Now, you'll notice the word Newton and Newtonian. Newton, Sir Isaac Newton, is who this was named after, the famous scientist. So, when temperature remains constant for a Newtonian fluid, the viscosity also remains constant no matter what force is applied to it. So the force and the rate of flow have nothing to do with the viscosity of a Newtonian fluid. Thus, a Newtonian fluid will continue to flow and act as usual no matter what type of force is applied. Water is an example of a Newtonian fluid. So no matter how fast you stir water or pour it or shake it, it will still have the same constant viscosity. Okay? So that's a Newtonian fluid. Now, you'll notice that these definitions are on your viscosity lab. So you should be copying these down. Hint, hint. Okay, so then what in the world is a non-Newtonian fluid? Well, a non-Newtonian fluid is the viscosity varies depending on the force applied to it and the rate of flow or the objects moving through it. So how fast or an object will move through it. So depending on the exact non-Newtonian fluid, it may become more or less viscous when a force is applied. When a force is applied to some non-Newtonian fluids, it will actually act like a solid. So some examples of non-Newtonian fluids are like ketchup, yogurt, or gravy. Now, when you're exerting a force to a non-Newtonian fluid, it can make it flow quicker and easier depending on the force that's applied. All right, so let's recap this. So viscosity is the property of a liquid that describes how fast or slow it will flow. It also talks about the resistance of the liquid to flow. So a Newtonian fluid has a constant viscosity at a constant temperature, regardless of how any applied force or rate of flow. Non-Newtonian fluid does not have a constant viscosity. It varies based on the applied force or how fast an object moves through the liquid. So that's kind of an overview of what we're going to be talking about in our lab. All right, so this is part A for our lab. So we must understand this in order to do the lab and do it properly. So in part B, I'm going to go on with part B, and this is just a discussion that I'm going to kind of have with you in a way. So part B, is cornstarch a solid, liquid, or gas, and describe it. So in the word cornstarch, I hear the word corn, and I know corn is a solid, and so if I take corn and I take the starch out of it, I'm pounding it into a powder. And so the powdery part is what I'm talking about when I'm talking cornstarch. So cornstarch is used for cooking. It's used to coat chicken, especially like in Asian cooking. Like if you've ever gotten sweet and sour chicken or sesame chicken, they put cornstarch on the outside of it to bread it. So cornstarch is a solid. It is in powder form, and it's a yellowish color. So it's a powdery yellowish color, and it is a solid. Is water a solid, liquid, or gas? Well, we can get really specific with this now. So water we know is a liquid, and when we were talking about this earlier, we were talking about water as a Newtonian fluid. Why is water a Newtonian fluid? Because it has a constant viscosity. So we could say water is a liquid, a Newtonian fluid that has a constant viscosity, and we could describe it as wet. Okay, so then the next part, it says, consider how force applied to a mixture of cornstarch and water may affect how the mixture behaves and why. So if we take cornstarch and water and we put them together and we mix it up, how do you think that that will behave? What will that mixture be like? What will it feel like? What will it look like? Can you pick it up? Will you have to pour it? Will you have to scoop it with a spoon? So that's what they want to know. So I want you to write a hypothesis. This is the end of part B. Write a hypothesis to tell me how you think that mixture will behave and why you think it will behave that way. Now, this is a hypothesis. This means that this is what you think from the information you know. So we know right now that we are putting together the cornstarch, which is a solid, and water, which is a liquid. So think about mixtures that you know like that you've experienced before. How does it behave? What does it look like? Okay, so use that information to make your educated guess on what you think will happen when we put this together. That's all I want you to do. And this does not have to be exactly what happens. Remember, scientists sometimes are wrong, but you take the information that you know and you write down your best guess of what you think will happen. All right? So I need you to have part A and part B of this filled out. And what you can do is you can go ahead and you can pause the video if you need to, or you can rewind and listen to anything that you need to in order to best fill out part A and part B. All right, so tomorrow is Earth Day, so we're not going to do anything with this lab tomorrow. We'll continue this lab on Thursday. Tomorrow I have some Earth Day activities that I want you to enjoy, and I also have a video that I want you to watch. So that will be for tomorrow. So this will be continued on Thursday. All right? So I want you to keep watching, keep thinking, and always remain curious. See you tomorrow during Earth Day.